Welcome back. Today we are going to start with the chapter complex numbers. Now before we start with complex numbers, let us understand the concept of imaginary unit or an imaginary number. Now in school we have been told that we cannot find the square root of a negative number, but now I am telling you that we can find the square root of a negative number. So for example, if you have to find the square root of minus 25. So here's what we'll do. We'll write it as root of 25 into root of minus 1. Now you don't know what to do with root of minus 1, but you definitely know what is root of 25. So that we will write as 5. Now what do we do with root of minus 1? Now root of minus 1 will be defined as I, and which we call as the imaginary unit. So root of minus 1 will now be called I, which is called the imaginary unit, and so therefore root of minus 25 will become root 25 into root of minus 1, and root 25 is 5 and root minus 1 will be written as I, and this 5I from here onwards we'll refer to as an imaginary number. So what are the examples of an imaginary number? You have of course this 5I, then you have minus 2I, 3I, 2 by 7I, etc, etc. You can just place any real number in front of I and that becomes an imaginary number. So 2 by 3I, 7I, 105I, anything is like that will be an imaginary number. It just has to have an I after a real number. Now let us understand the higher powers of I. I have just told you that I is root of minus 1. So suppose if I were to square both sides, so I square would become, and then the root would go away, and so therefore I square would become minus 1. So I square is equal to minus 1 is an important value. Suppose I were to find I cube, that is I square into I, out of which I square you know now is minus 1, and so I square is minus 1 into I, and therefore I cube will become minus I, again an important value for us. I raised to 4 is I square into I square, you know I square is minus 1, so that's minus 1 into minus 1, therefore it will become 1. So I raised to 4 is 1. So three important values: I square is minus 1, I cube is minus I, and I raised to 4 is 1. In general, if you have I raised to 4n, the value can be directly written as 1. If you have I raised to 4n plus 1, then you can replace that directly by I. If you have I raised to 4n plus 2, then that gets replaced by minus 1. If you have I raised to 4n plus 3, then that gets replaced by minus I directly. Let us take a few examples to understand these four things. So if you have I raised to 24, so that's I raised to 4 raised to 6 as per indices. So it's a multiple of 4, so I can write it as I raised to 4 raised to 6, and I raised to 4 you know is 1, so it's 1 raised to 6, and you get the answer as 1. So this is basically an example for I raised to 4n equal to 1. So you can actually understand that if 24 is a multiple of 4, you can directly replace that I raised to 24 by 1 as per this generalization. Now I raised to 37 is one number above 36, which means and 36 you know is a multiple of 4, so it's I raised to 4 raised to 9 into I raised to 1, so that's 1 raised to 9 into I. The answer will be I. So this is an example for I raised to 4n plus 1. If you have I raised to 18, that is 16 plus 2, isn't it? So I raised to 4 raised to 4, that's 16, into I square, so that's 16 plus 2, 18. So that's 1 raised to 4 into I square you know is minus 1, and so you get minus 1. So that's the example for I raised to 4n plus 2. And I raised to 83, you know it is 83 is 80 plus 3, so I raised to 4 raised to 20, that's your 80, into I cube. So 1 raised to 20 becomes 1, and I cube you know is minus I, therefore the answer will be minus I. So that is an example of I raised to 4n plus 3. I'll take a couple of more examples. If you have 1 upon I raised to 49, so I raised to 49 is raised to minus 1. So I raised to 49, you know 49 is 48 plus 1. So this is I raised to 4 raised to 12 into I raised to 1, the whole raised to minus 1. You know this one, this I raised to 4 is 1. So 1 raised to 12 into I raised to 1. So that's I raised to minus 1, so that's 1 upon I. And suppose we take a higher number like I raised to 400. You know 400 is a multiple of 4, so it's I raised to 4 raised to 100. So that's 1 raised to 100, and it is simply becoming 1. Now let us take up the definition of a complex number. Now what is a complex number? A number of the form a plus bi where a and b both are real numbers, and where I, of course, is your imaginary unit, minus 1, root of minus 1. So a plus bi is called a complex number, and it is denoted by z. So z is equal to a plus bi becomes a complex number. Why is it a complex number? Because it consists of two things. What are those two things? What is a? A is referred to as the real part of z, and it is denoted by re of z because it is purely real. And b, which is attached to I, which is the imaginary unit, which means bi is an imaginary number, isn't it? So b is referred to as the imaginary part of z, and it is denoted by im of z. So let us note a few things, that if suppose the real part of z was 0, which means if a was 0, then z would be simply bi, and what is that? That's an imaginary number. So we say that in that case z is called a purely imaginary number. If the imaginary part of z on the other hand is 0, then z will be simply just a, right? It won't have this bi term, and so therefore in that case your z will be a purely real number. Okay, and in the third case, if suppose the real part of z is also 0 and imaginary part is also 0, then in that case your z will be called a zero complex number. That is quite obvious. Now let us come to the next property of complex numbers, which is equality of complex numbers. Now suppose I have two complex numbers, z1 equal to a1 plus b1i and z2 equal to a2 plus b2i. So if these two are supposed to be equal, or if these two complex numbers are said to be equal, then you know for sure that their real parts will be equal, and simultaneously their imaginary parts will also be equal, meaning that a1 and a2 will be equal and b1 and b2 will also be equal. You cannot have an either or situation. You can't say that, oh, if the real parts are equal and the imaginary parts are not equal, still the two complex numbers are equal. No, that won't be possible. For two complex numbers to be equal, their corresponding real parts have to be equal, and their corresponding imaginary parts also have to be equal simultaneously. Now I'll give you an example. Suppose I tell you that x plus iy is equal to 2 minus 3i, then I can straight away say that x is equal to 2 and y will be equal to minus 3. And if suppose I tell you that x plus iy is equal to 0, then I can straight away say that x will be 0 as well as y will be equal to 0. This is that zero complex number I was talking about. Now let us move to the next property of complex numbers. Now the conjugate of a complex number. What is the conjugate of a complex number? Suppose you have a complex number z is equal to a plus bi, then the conjugate of this complex number a plus bi will be a minus bi, and it will be denoted by z bar. So what have I done? I have just changed the sign of the imaginary part. That's it. I have not touched the real part at all. A remains a, but bi becomes minus bi. So if suppose the original number was a minus bi, then the conjugate would become a plus bi. So you have to change the sign of the imaginary part only. So let us take a few examples. Suppose z is equal to 3 plus 2i. So the conjugate for this will be z bar equal to 3 minus 2i, right? Yes. Suppose you have z is equal to 4 minus 3i. The complex conjugate will be 4 plus 3i. If you have z is equal to minus 1 plus 7i, z bar will be minus 1 minus 7i. Z is equal to minus 2 minus 4i, your z bar will be minus 2 plus 4i. See, I haven't touched the real part at all. Minus 2 remains minus 2, only the minus 4i has become 4i. Suppose I have z is equal to 9i, so z bar will become minus 9i. And suppose I have z is equal to 5, it's a purely real number, then z bar will remain 5. You are not supposed to touch the real part. If there is an imaginary part in your complex number, you just change the sign of that. The real part is not touched at all. So z is equal to 5, the conjugate will remain 5. Now let us move on to some more properties. Let us come to algebra of complex numbers. Let us understand how to add and subtract two complex numbers. So if you have z1 is equal to a plus bi and say z2 is equal to c plus di. So what is z1 plus z2 going to be? It will be simply a plus bi plus c plus di, and you simply just add the real parts and you add the imaginary parts, just like how you would collect the like algebraic terms, right? Even when it comes to subtraction, you will just simply subtract the real parts and then you will also subtract the imaginary parts. So I've taken an example for both. You have 2 plus 3i plus 4 plus 3i. So the answer to that will be 2 plus 4, you write as 6, and 3i plus 3i will become 6i. Suppose you have minus 2 plus 5i minus 3 minus 4i. In that case, this will become minus 2 minus 3, which will become minus 5. 5i minus or minus 4i will become 5 plus 4i. 5i plus 4i becoming 9i. So that's minus 5 plus 9i. Now there are some properties of addition that you have to understand. Suppose you have z1 plus z2, that can also become z2 plus z1. So you can add it in any order. If you have three complex numbers to be added, z1 plus z2 plus z3, you can add any two first and then add the third one to it later. So z1 plus z2 plus z3 can be written as z1 plus z2 in a bracket plus z3 afterwards as well. Suppose you have z1 plus 0 or 0 plus z1, that will simply remain z1. That is very obvious. Suppose you take a complex number and add it to its conjugate. In that case, you will get 2 times the real part of z. Let us understand that through an example. So if you have 2 plus 3i as your complex number, obviously its conjugate is z bar, so that is 2 minus 3i. So if you were to add these, you know your 3i minus 3i is going to get cancelled, and so you'll get 2 plus 2 becoming 4. That is basically the double of the real part of z. So if z is 2 plus 3i, you know the real part of z is 2. So you're getting the answer as 4. It means you should get a 2 times of a, or 2 times real part of z. Now let us see the multiplication. So I have z1 is equal to a plus bi, I have z2 equal to c plus di. So let us multiply z1 and z2, a plus bi into c plus di. So you will simply multiply this like how you do in algebra. So a into c is ac, a into di is adi, bi into c is bci, bi into di is bdi square. Now I'll let the AC be as it is. ADI plus BCI, I will collect them in a bracket. So that's AD plus BC in a bracket into I, plus BD into I square, you know, is minus 1. So this BD into minus 1, that's minus BD. So that is a real number, or that's the real part which gets collected with AC. So AC minus BD comes in a bracket plus AD plus BC into I. So when you multiply two complex numbers, you're eventually going to get a complex number only, right? Now I'll take an example. I have minus 2 plus 7i into 4 plus 2i. So minus 2 into 4, you get a minus 8. Minus 2 into 2i becomes minus 4i. 7i into 4 becomes plus 28i. 7i into 2i becomes 14i square, and then I square becomes minus 1. So that's 14 into minus 1. So that's minus 14. Minus 8 minus 14 becomes minus 22, and this plus 24i as it is. Now let us understand a few properties of multiplication. z1 into z2 can always become z2 into z1, so you can multiply in any order. If you have z1 into z2 into z3, you can multiply any two first, so you can multiply z1 and z2 first and then multiply the result of that with z3, or you can simply multiply z2 and z3 first and then you multiply z1 to the result of that. If you have a z1 into 1 or 1 into z1, it simply becomes z1. That's quite obvious. Now here's the important part. If you multiply a complex number with its conjugate, you will get a purely real number. So let's understand that. So let's take an example. You have 2 plus 3i. Let's multiply that with its conjugate. So multiply by 2 minus 3i. Now you know this is a plus b into a minus b. So that is simply a square minus b square. So that will be 2 square minus 3i whole squared. So that is 4 minus 9i square, out of which I square you know is minus 1. So this sign in the middle will become plus. So 4 plus 9 will become 13. Now let's understand this. Let's note this down, that if a plus bi is multiplied by its conjugate, which is a minus bi, you will get a square minus b square I square. Again, I told you I square is minus 1, and so you get a plus sign in the middle. You get a square plus b square as the product of a complex number with its conjugate. A square plus b square, obviously this is purely real. But what you understand from this therefore is that if you were to multiply 4 plus 2i with a 4 minus 2i, which means a complex number multiplied with its conjugate, it is simply a square plus b square. So if 4 is a and 2 is b, the answer will be simply 16 plus 4, straight away 20. So you need not really open out the bracket or write it as a square minus b square. You can simply just take the square of this number plus the square of this number, and that will be the answer to this. It will be a purely real number. Now I'm going to use this idea that when you multiply a complex number with its conjugate, you get a purely real number. Now I'm going to use this for the purpose of division. I'll show you now. Now let us understand the division of complex numbers. I've taken an example, 2 plus 3i upon 4 minus I. So I have to divide 2 plus 3i by 4 minus I. Now, like I told you, I'm going to use this logic that if I multiply a complex number with its conjugate, I get a purely real number. So I know how to divide by real numbers, right? We don't know how to divide by complex numbers. So if I were to convert this 4 minus I to a real number, it will become easier to divide. So how do I convert this complex number to a real number? I multiply and divide by its conjugate. So I will multiply and divide by the conjugate of 4 minus I. So I have to multiply and divide by the conjugate of the denominator. So I have to multiply and divide by 4 plus I, right? So in the denominator, it will simply become a square plus b square. So that is 16 plus 1. So the denominator will become 17. What happens in the numerator? It is a multiplication of two complex numbers. So 2 into 4 is 8, 2 into I is 2i, 3i into 4 is 12i, 3i into I is 3i square, out of which the I square is minus 1. So this sign will become minus. So you'll have 8 minus 3 becoming 5 and 2i plus 12i becoming 14i. The whole thing is divided by 17, and now I know how to divide by 17. I simply split this up. So 5 by 17 plus 14 by 17 into I, you get the division of 2 plus 3i upon 4 minus I as 5 by 17 plus 14 by 17i, meaning that the division of two complex numbers is also a complex number. I hope you understood all the concepts that I taught you today. Until next time, goodbye.